Welcome. I live in Austin, Texas, or near Austin, Texas. And right off the bat, I want to apologize if my voice fades or the screens freeze up. I live in a very rural area. The fastest internet we have is 25 megabytes per second going out and 10 dropping down. So if something happens, please let us know so that I can either pause or and let the system catch up or whatever. But anyway, I'm glad to be here. I really enjoy talking about now come on. Okay, there we go. So we're talking about, this is a topic that I've been fascinated about it, and I've been thinking about this for over 3 years. In fact, somebody, when I was at SQL Saturday, Colorado Springs, almost 3 years ago, said, why don't you do since you're so interested in indexes, why don't you do a session on fill factor? And I thought about it for a year, and I said, I don't even know how to start with fill factor because I just don't know how to even begin with it. So I'm Mike Byrd. I'm a consultant. I do performance training in the Austin area, and also I've done a bunch up in the Dallas area too. I used to fly F4s in the Air Force. I've been a SQL Server geek for 24 plus years, and I also freelanced for PC Magazine. I was a senior software manager for a government-sponsored munitions effectiveness committee, and also was an insurance company CTO. But one of my best things that ever happened to me in my life was that I got I got fired from being an IT director at the insurance company, moped around for 2 years. One of my contractors called me up and said, Mike, can you come work for a couple of days? Ended up being 2 years. And since then, I've just been back on the technical side, and I just love doing it. So that's me. There's my contact information. The slides will be available, or this all being videotaped, so you can get back to them and see it again to get all the contact information. And again, I said I live near Austin, Texas. The little picture in the upper right-hand corner is what I see every morning. I live in the town of Sunrise Beach, and obviously there's the sun coming up. It's a hardship, but somebody has to pay the property taxes. Okay, the presentation slides and TSQL code probably are available at either a Dropbox location, or probably the best place to get it is just go to github.com and just remember MByrdTX, Mike Byrd TX, Texas. It'd probably be to your advantage just not to take notes, but just listen and review the slides. And you can always contact me via email, LinkedIn, or however to explore where we go from here. And that's Shania Twain helping me out there. Yes, that's everything I talked about before. I've been blogging a lot over the last many years, initially for logicalread.com because they paid me, and then at SQLServerCentral.com because Steve Jones was nice enough to give me a little stipend there too. My current goals is I just like to dig deeper into the optimizer black box and just be a geek about it. So today we're going to talk about fill factor, what it is, how it's used, and approach that I ended up taking. We'll look at a short review of the code. There's not going to be any demos, but we will talk at numbers and see some numbers, analysis of how I reviewed the data that was coming in, and conclusion observations. I really would like for this to be an interactive session. If you have questions while I'm talking, ask, because at the end, I'm going to put it on all of you to respond back to me with, how can I make this even better than it is? And I think it's good already. There is an early version of the code presented in SQLServerCentral.com. There's part 1 and part 2. But the latest code is at GitHub or Dropbox locations, as I talked about earlier. Everybody's seen a B tree that sort of looks like this, and you see the big arrow or circle with the arrow through it, and that's not really right, because when you look at a B tree, it really looks skewed. And the reason the B tree is so efficient is that at the intermediate level and the root levels, all you're carrying are pointers to where the data is, and the data obviously is down at the leaf level, regardless of whether it's a clustered index or a non-clustered index. But that's sort of how the B tree really shows up. Normally, when you populate a table, normally in 98% of the time, it's going to populate page by page by page. It'll start off with a mix extent, and then as soon as it fills up the existing extent that it's in, then It moves on to or extents where there's only the index data itself is there. But in reality, it just fills it up regardless of what the fill factor is. We haven't talked about what it is yet, but regardless of what the fill factor is, it's going to fill up the page as best it can. With one exception, and you look off to the right-hand side of the slide there, Jeff Modem found a case, and there's a reference to it where sometimes there are certain instances of a clustered index, it can fill it up just to the fill factor level itself, whatever it happens to be. So what is fill factor? Fill factor is percent of the fullness of the leaf pages. Default is 0, which is a synonym for 100. So in the default for SQL Server is 100, depending on unless you have reset it somewhere else. So what happens if you fill it up to 100, you can't, and you want to add another row, what happens then? And you get something called a good page split or a bad page split. Good page splits are usually indicative of where you have like an identity column for your primary key / clustered index, and it just adds to the end. So when it fills up a page, and I'll show you a picture of this in a second, it'll go out and just keep adding pages at the end of the linked list. However, for bad page splits, I did a case study, and there's a link to it. And for this particular case study with my laptop, which would have made a great server back in the late 90s, it had average page splits were on the order of 0.035 milliseconds, but the logical IOs for a single bad page split averaged in this case study 6.1. And that can be significant if you're thinking about what happens. And I'm not going to go into that case study now, but you have the link to it and you can get to it. The trick when you're using fill factors, try to find a fill factor value that minimizes bad page splits but doesn't result in excessive storage penalty. No questions? I don't see them. So
nope, no questions.
So for the last 3+ years, I've really been diving into index and their effect on performance. But all this time, I've never really understood how to determine fill factor for an index. You know, frequently we just use the default 100 and just go from there. There is some guidance, but there's no definite path for how to determine whether you want 90 or 88 or 72 or whatever for it. It's just no definitive guidance. So I was really pulling out my hair until about a year ago. And let's talk about a story. A long time ago, no, that's the wrong sequence of events there. Back April a year ago at SQL Saturday 8:30, which was in Colorado Springs, I attended 2 sessions by Jeff Modem titled Black Arts, Index Maintenance, and How the Best Practices Methods Are Silently Killing Performance. These were outstanding sessions. You can download them at the link they show there, but they really got me to thinking. And so on the flight back, well, and a Reader's Digest of his presentations is contrary to Ola Hallgren's popular concept to reorganize at 10 and rebuild indexes at 30. Essentially, he showed in the 2 presentations that page splits cause tremendous performance degradation. So you can see that from the numbers I showed you on the previous slide, and that you should probably rebuild your indexes at 1%. I'm not sure I go exactly 100% with that, but I think he's definitely going down the right trail. So on the flight back from Colorado Springs to Texas, got to thinking about everything that Jeff had said and how fill factor also factors into index performance and maintenance. And so with that thought in mind, it got me to thinking about a brute force optimization technique I implemented way back when I worked at the Air Force Rocket Propulsion Laboratory. Yes, I was once a rocket scientist and I'm still a geek. And that's probably the reason I still work, is because I always loved solving problems. This was a technique that involved tweaking various parameters and going plus or minus percentages and reducing the tweaks to where it kind of closed in on an optimum solution. This particular technique is a brute force type technique. It's not always perfect and may not find the exact perfect value that you're looking for, but in a multi-dimensional scenario, it could dive into a valley that it couldn't get out of, but it still gave us a better number than what we started with in almost all cases. So the approach I took is I took a technique similar to Ola Hallgren's defrag script and I modified it accordingly. His script reorganizes at 10% fragmentation and rebuilds at 30% fragmentation. Even before I attended Jeff's session in Colorado Springs, I had already modified his script to have no reorganizers, and then I was doing rebuilds at 10%. And that was for one client that I am their accidental DBA. I've been with them for 12 years, and this is what I found was working best in their particular situation. And so to do this, to tweak and see what the effect is if you decrement fill factor by 2 and see what the new fragmentation is, and then check to see what it is the following day, you need some type of way of tracking that. And so I created a table to contain the parametrics involved with the whole rebuild process for each rebuild. So initially I started off with a table sort of looked like this. So I'm not going to go through column by column, but it was a table that allowed me to track information on every index in the table that met certain criteria. And initially, when I first started this, which was roughly March of last year, all I did is collect data and tweak the fill factor. I did not force a fill factor to a final value yet, because I was looking to see, well, what kind of data do I have, and what am I getting, and what is it showing me any indications of where it might be going to minimize bad page splits and fragmentation both. So to cut down on overhead for the server, and I put this on a production server. I got the top 20 indexes with the worst fragmentation. Later on, I also looked at it from the bad page split point of view, and I'll show you that in the code in a little bit. And then from that point of view, so from OLS defrag script, we can get average fragmentation percent from sys.dmdb index physical stats. And we also get some other information from sys.dmdb index operational stats. And then, thanks to Jonathan Cahias at SQL Skills, this follows real well with Grant's session in front of me. He had created an extended event that allows you to track bad page splits. And he supplied the code with it at that link that you see there. But then you have two kinds of fragmentation. You have logical fragmentation. That's where you have fragmentation of database files in the file system. And uniform extents are owned by one object, but mixed extents can be shared by up to 8 objects. And every time you do a rebuild, it's going to start off with the mixed extent and then move to uniform extents after that. So we have two types of index level fragmentation. We have internal fragmentation, which is too much free space. That usually occurs when you have large deletes. And so if you have large deletes and there's data missing out of pages, but maybe not all the data is missing out of every page, then you're carrying along essentially something where the average fragmentation is what may be well below what your fill factor is set to. And then we also have external fragmentation where you have pages out of order. Internal fragmentation is measured in average page fullness. One that's at 100% has no internal fragmentation, can occur with deletes. Like I said, it will increase IO because now to get X number of rows, you have to probably read more pages than it would have been if it was at 100%. It decreases the efficiency of the buffer cache because the missing rows are taking up space, and increases the size of the database file. There's a link there if you want more information on and words to go along with it on index fragmentation. External fragmentation occurs when the logical order does not match the physical order. That can make a difference, like if you're doing a range scan or range seek. If the pages are out of order, then the SQL server is having to jump around to try to find those particular pages. It measures percentage of out of order pages and the leaf pages of an index. So let's take a part of what a B tree might look like. So you got your root level, your intermediate level, and your leaf level. If we were going to add a row to this, which was just an increment of like the identity column, then if there's no room in the third page, then it's going to jump to the fourth page, and that creates, you then have to have your linked list going back and forth between the original old page and the new page, and then you also have to add it up at the intermediate level, the value that's been there, and that goes up into the root level. So that's what's called a good page split. It's if it can stay in the same extent, it does. If you run, if you used all 8 pages in the current extent that you're in, then it goes to a new extent. And I hope everybody understands extents, because I'm not going to go into it much more. It's possible, though, that when you added the row and it created a new page, that there may not be enough room at the intermediate level to accommodate the pointers to the new data, so you may create an extra page in the intermediate split. So it's possible to have page splits not only at the leaf level, but also at the intermediate level. And worst case possible is that if you added enough data to where the pointers couldn't all fit up in the root level, you may go up one more level in your roots just to accommodate the data structure. Okay, so, but let's look at the case where you have a bad page split. Let's say that you're going to insert data in the second page here shown at the leaf level here, and there's not enough room for it. So what does SQL Server do? So SQL Server goes through and finds a page that's not in sequence with the other ones, and now moves half the data out of the old page to the new page, inserts the new row, and then it has to create all the pointers going back and forth. And you're not only talking about pointers between pages at the leaf level, you're also talking about pointers at your intermediate level. Obviously now, if that new bad page split is on a different extent, now you have to jump around, or SQL Server has to jump around to find data if you're doing a scan to move back and forth between the range scan that it's trying to seek. So I'm going to jump over now to, that's what did I do with it? I lost my, oh, there we are. Okay, and let's maximize this. So I have 2 scripts that are available, and these are available to everybody, and I would love your feedback at some point in the future. The production server I'm running on was running always on, so I had to have code in there to see if this was running on the preferred replica or not. And because I had to start it with the begin and then see if the schema exists, and the schema, I added admin schema, and then the name of the new table that I'm going to put it in is agent index rebuilds. And because it's a good old error that SQL Server has of wanting a create table statement to be the first in a batch, I had to use dynamic SQL to create it. And then about 5 weeks after I started collecting data, I found Jonathan's blog on bad page splits, and this code is directly from his blog there, or indicated by the web link. And so if it exists, I drop it. If I create the event session, and then I turn it on. So this right here, this is my setup script, and this generates the extended event that's going to allow me to track bad page splits. And then later on, I was just wanting, and this is not part of the fill factor determination at all, I created another table just so I could monitor what was going on bad page splits by table, index, and partition number. Now, the actual script that I run nightly, and it's running the SQL agent job, and I'll show you that in a second, is this script here. And I've really worked hard at trying to make it as easy to read as I can, and I hope all my documentation is good for you being able to use it. But I have a redo period of 90 days, and we'll talk about that in a few seconds. And then I have a work count, and right now it's set for 20 for this particular database I was using, because I didn't want it to get all the possible indexes that exceeded the fill factor that I asked for, but we just take the top 20, and I'll show you that. And then a bunch of other informations, but some of the things that where'd my lag date go? Okay. I have a work date I found after watching data for a while that obviously weekends, the workload is not as heavy as it is on weekdays. So I have a work date where on Saturdays and Sundays, it has a value of 0, else it's 1. And some other. And interestingly enough, when I presented this at Baton Rouge last August, I got a bunch of good comments back that I've incorporated some of their comments. In fact, if you go back up here in my documentation, you can see I gave credit to this individual here because he added logic to check some of the SS version and some debug flags. But come down here, this is the query that I use to find the top 20 worst performing indexes or having the most fragmentation. And it generates a lot of stuff that's going to eventually end up in that table that I told you about. And I had to prevent duplicates from coming in, I had to use the row number window function to and set it and check down here later on where it's 1. But the code that actually goes out and from Jonathan Chaos to get the bad page splits is right there. And I found for this particular database, you know, as I said earlier, Jeff Modem said you should fragment or rebuild from fragmentation is greater than 1%. Well, I did it with 1.2. 1 was just, it just wasn't working. It just looking at the data, it just wasn't working. And then I have down here in my order by clause, I alternate by day. I order by fragmentation descending, or I order by bad page split divided by the page count for that particular index descendant. So one day it's ordering by the fragmentation descendant. The other next day it's ordering by how many bad page splits by the page count. And the reason I divide by page count is because it was looking like to me that I needed to be able to weigh the size of the index with bad page splits to see what was working and what wasn't working. And this right here is just that one table I talked about that collecting bad page split data, similar to what is above, but that's what I did. Okay, now the code itself. Okay, so every night when I run this, I run it and I stop the event session because I've already got the bad page splits up above and restart it. So with the restart, now I'm gathering new bad page splits from this time going forward. Then I also, after a long period of analysis, looked at and say, well, what happens if the data changes its skew, or we add new tables, or we add new functionality within the database itself. And so now that may cause how fill factors need to be looked at. So essentially when the data gets 90 days old after I've set it and fixed it, I go back and pull out just one index, the worst performing at the time, to see, let's go back and retry again and rerun the excursion of tweaking the indexes. And so if it's a non-clustered index and it's a primary key, I set it back to 100. And if it's a non-clustered index and the fill factor is greater than 90, I set that back to 100. If the index is not non-clustered, I set it back to 80. And these are numbers I just pulled. I just said, look good to me. And else I set it back to 100. So if I reset for that particular index, it's already had a fill factor, but I'm going back to relook to see, well, is there any way I can tweak it to make it even better? I've used this criteria to do it. I have a del flag parameter. It's a soft delete because I don't delete rows out of it until it's barely owed, and you'll see that at the very bottom. And now I insert that one row into my work table. Okay, so now I have a cursor to go through all 20, if I have 20, all 20 of the indexes that are found up above from work to do. And then and with this cursor, I look at index by index, and I go through and here's my fetch status, and so I look to see if the index. Well, this part of the code right here is where I look to see how I can set and fix the fill factor, and I'm going to talk about that in a little bit later. But the code is here to look at, and do I have at least 6 entries? If I don't have 6 entries, I don't set it. And if I do have 6 entries, or is there a number between 1 and 6 that is fragmentation-wise smaller than the previous and smaller than the subsequent one? And I go back through and set up, and I'm looking for setting at fixed fill factor. And if I go way back over to my table up here, you can see I have a column there, and that's the final fill factor determination. So let's come back over to here. And I know this, I hate people going through code like this, but this is the only way I thought I could show you what was really going on. And this is where I want y'all's comments back if there's anything better I can do. Obviously, if the table's partition, I really should not rebuild or play with the fill factor on that. And that's a point I'll bring out at the very end that Microsoft needs to fix. That, in my mind, partition tables should be allowed to have different fill factors depending on the partition. We'll talk about that a little bit. And then the logic for setting or for tweaking the fill factor, obviously it's on Monday through Friday that I do it. And you can see here, I look at clustered indexes, clustered indexes, clustered indexes, non-clustered indexes, non-clustered indexes, and non-clustered indexes. That covers them all. I don't look at heaps. And then I arbitrarily, because I never want to see the fill factor go below 70, that's just a number I use. If it tweaks above there, the code tries to take it below 70, I set it back to 70. And then dynamic SQL, and then alter index and with the rebuild. And somebody asked me about data compression earlier. Row, I can, no matter what, I've never seen a case where row compression has hurt performance. Yes, somebody can argue that it takes 0.5% of your CPU, but if you're that tight on your CPU, then you got other issues besides that. And then the fill factor set to whatever the fill factor is that I tweaked up above. And if it's not, if its partition flag is 1, in other words, it is a table's partition, I just rebuild it. And if it's a work day, Saturday or Sunday, I rebuild also. Okay, and then I come back down and I do the insert into my table. Okay, enough of this. This is boring y'all to death, and maybe everybody's asleep by now. I do look at the end, and for the soft deletes, if I get rid of data that's 1 year old, if I have a soft delete on it, and if I don't have a soft delete on it, I get rid of it after 3. So let's go back to there and come down. And this is I initially put it in defrag indexes for my SQL agent job, and you can see I have the code I was just looking at over here on the left, and it runs for this particular installation. Their lowest server activity is usually between 8 and 10 p.m. And so I run it at 8:20, and it usually runs in the vicinity of 60 to 75 minutes total. And that includes coming back up here, there are other steps that were update statistics and get index capacity. And the index capacity is just something I'm watching on the side to make sure my indexes are not going to run out of space. So what do we have here? So I watched this for about 4 weeks before I ever made an attempt to set a fill factor. I watched it decrement and watched the fragmentation and the bad page splits, and going from 100 down. All my indexes at the time were at 100% fill factor. I run it during low database activity as the data is collected. I did add some new columns to the history table and revise logic to determine and or fix the fill factor for each index. And we'll talk a little bit about that in a second. Eventually, then, as I said earlier in the code, I saw a need to retweak the fill factors after a period of time. Right now, it's 90 days to allow for new patterns and data access and so forth. Okay. Luckily, this particular client, trust me like you wouldn't believe, I've been a client or his accidental DBA for 12 plus years. He's scared to death and retire on him. But anyway, there was 225 gigabytes of real data. That does not include the sprocks, the views, or anything else. That was actual real data. The 249 tables, 694 indexes. It runs in 24/7 environment. In a 90-day period, there were only 164 indexes, clustered, non-clustered, that were recorded in the history table, and the fill factor were tweaked. And I actually was still tweaking some even after the first 90-day period. I'm not going to go through, I put these numbers here for you all to look at if you want to later, but really what I want to show you is what was happening. And this is for a clustered index. And you can see this one particular one started at 91 and went down to 89, then 88 fill factor, then 87, it went back up. And so I manually just fixed it at 88 and it stayed. So the lowest fragmentation, and the fragmentation is on the left, fill factor is at the horizontal axis. It gave me an idea, but let's look at a couple others and tell you why. Again, don't worry about the numbers because they're all right here. This was a strange one for me, another clustered index where the at 100, it was a value a little bit over 6 fragmentation, dropped down at 99 to under 2, and then from 98, 97, it went back up. And I'm going, it may have been a bad number. And I checked to make sure that wasn't a weekend, and it wasn't a weekend. So anyway, again, right here for this particular clustered index, 96 appeared to give the best numbers. And you can see they kind of level out and you start decreasing. But you don't, if you lower the fill factor, the more space it's going to take, and you don't want that. So you want to try to minimize your space. And there's some numbers again. Which way am I going? Yeah, okay. And this is one I let run for a long time, and mainly because I overlooked this particular index. This is a non-clustered index. You can see it dropped down and started at 93 and dropped down to around 83, and then at 79 and 75, and went all the way down to 71. And then that's when I looked at it. You can see I stabilized at 83 and it stayed at 83. But 83 looked like the min fill factor here. So if you're starting to see a pattern here, I was, and that's how I kind of determined when I was going to set it. This was another interesting non-clustered index. It started at 85, dropped down to 83, the same value for 81 and 79. I said, well, you're going to pick the maximum of these three. So what I did then is I collected 6 data sets for each index, at least 6. I wouldn't even look to see what I was going to fix the fill factor unless I had 6 data sets. And then I find the smallest fragmentation, but not in the first 2 data sets, sets 1 and 2. And obviously not the smallest in the last data set, because there's the smallest in the last data set, I need to tweak the fill factor down again one more time. I continue to per, and that's what I say in the next bullet. Identify the fill factor for the smallest fragmentation and set fixed fill factor, which is in that history table. The script then checks fix fill factor and stops tweaking when it's not null. So if I set it, then it stops tweaking it, and it won't even bring it into the work to do table that we had. This is probably one of where I can take a lot of hits. I did not really have good benchmarks for performance, but using database performance analyzer, which I really like because it gives me a real-time view of what's going on instantaneously with the last 10 minutes on the server. The average over an hour was somewhere between 350 and 500 milliseconds or seconds. And those are 10-minute periods down below. That was before I started doing any of the fill factor stuff. Then afterwards, it dropped it down to where the average was on the order of 300. So 350, 400 to 300, somewhere in the order of 25, 30% decrease in wait times. And if you know anything about DPA, they have an extra wait type that's not a Microsoft wait type. It's the actual execution of the query itself measured in the CPU. And that is part of, that's included in this here. And majority of the, and every one of these colors is a different index, looking up and down. And I observed about, like I said, 25 to 30% decrease without me doing anything in the way of index tuning. This was just straight reduction of page reads, bad page splits, whatever. Yes, I know the different times, but the screenshots were indicative of performance because I watched that daily on the DPA. With decreased fragmentation, obviously there are less page splits and to have to wait through for IO range searches. With improved fill factor, there should be a lot less page splits, and the cost is going to be significant. You saw earlier in my one our presentation, I linked to that 6.1 IO page IOs can be significant if you're doing very many bad page splits. So, what do you need to do to run this? Well, it should be SQL Server 2012 and above, mainly so that it can pick up Jonathan Caius's bad page split portion of the script. The enterprise version is recommended because the online option, and with 2016, you can now use, even with 2016, standard edition just can be used, but you have to be where your schema locks. Data compression equal row, and I already have that in enterprise, and then 2016 Service Pack 2 and above for standard edition, you have data compression. I have another presentation on data compression, and I just can't see a reason not to use it. Okay, so wish list. What needs to be done? What do I need? What more would I like out of this here? An add code for multiple databases. I have some coding already in there to push us that direction, but it's not implemented yet. May want to have the separate database for a history table then. It'd be nice to determine best performance for fill factor values versus pages used. That's something that I'm still mulling over on how to resolve. Don't have a good answer here yet. The code probably needs to be written. It's what I wrote for the proof of concept, and the proof of concept, as anybody well knows, tends to stick around for a long time before it gets worked on again. The current fill factor approach is not implemented for partition indexes because you would like to set your old data partitions to 100% and the active partitions set as needed. I placed this a couple of times on Microsoft's wish list, but they seem to ignore me. If you're using partitioning, I think you should also have it on the wish list. And this is where I like your inputs. Try and build additional features as suggested by the community. And more testing on performance improvements with firm numbers. I really would like to. I don't have access to another production database that we could try this on. I'm really interested, and I've been thinking about it for a long time. How would this work on a terabyte database or a 2 terabyte database? It may need some tweaks and things I hadn't thought about. Need a better way of monitoring. I monitor and look at, or was looking at on a daily basis, the history table, which is age index rebuilds, but it needs some type of self-review. I was wondering if there are any volunteers out there who may want to implement a dashboard. If so, get to me. I would appreciate it. Code into GitHub, I've already done that, and you can go to Byrd TX and you'll find not only this presentation, but the code for the setup and the code to actually put in SQL agent. And finally, I think I need, and maybe this is part of the dashboard, some way to compare the index growth by fill factor versus performance. So what am I doing? Well, I'm still looking at it, but I'm really happy, and so is the client. I have not had a 2:00 a.m. phone call since we've done this. It started as a proof of concept. It offers some performance benefits. It's demonstrated, and that the effective automatic determination of fill factor is possible. Whether I'm doing it the right way or not, I don't know, but I would love feedback on that. And the current code has been in production for 14 months. And like I said, I have not had a 2 a.m. phone call since. I've copyrighted this with the idea that it belongs to the SQL Server community. It doesn't belong to me. I just implemented it. What I'd like is for us as a community to, if you find this worthwhile, to embrace it and to help me make it even better. And again,